What's up guys, this is Ben from 606X, and today I'm going to be explaining the miscellaneous stuff of our robot. So, you might have already seen our catapult intake explanation, but now I can explain the stuff that like fills in the gaps, I guess, of this system. So to shoot an auton, we have this cylinder right here on either side, and then it's basically connected to this bar up top for just geometry reasons. And then it's attached to this arm here. So we have it connected on both sides. So if we want it to be boosted, then we want the air to be pulling up on the catapult. So the cylinder wants to retract, and that makes it shoot a lot further. And then when we want to make the shot less powerful, then we have the cylinder push out. So pushing, like extending, I guess. And then this lowers the shot of the catapult. And one thing that's really cool about our catapult is that we have variable shot power with all of our pneumatics tucked in here. We have this regulator right here, and this allows us to have so we twist it out to have more shot power, and then twist it in to have less shot power, because this basically increases or decreases the amount of air inside of the cylinder when it's extending, meaning that we can adjust how much tension the cylinder has and how much we can shoot by. So I can show a quick video of the different powers of our intake, or I can show a quick video of the different powers of our catapult. And this is on high power, which shoots a lot further. Alright, so this is on low power. You can see it doesn't shoot very far. So with these two stages of shooting, we are allowed to change in between auton shooting and match shooting, which allows us to have the perfect grouping, which is the advantages of the SCADA, but then also we can shoot from different places on the field. This banding tension is actually right in the middle of the two, so we never actually use the middle banding tension because we don't need to. We can move on to sort of the coding aspects of the robot. So we have two distance sensors here and here. This allows us to read the distance to the walls, so we can reset odometry and our XY values on the field. And then we also have our odom pods. We're actually using them this time, which is really nice. So they're geared, actually. They're geared odom pods, and they're super skinny, which allows us to fit them inside of the wheel, or inside of the drivetrain, I guess. So you can see here, it's a 2.75s with a 60 tooth geared to a 36 tooth. Let's see if we have a better view. Yeah, so they're hinged and they basically spin like this with the wheel and the gears spinning. This allows for more slop. This allows for more accuracy with the wheel. As you can see here that we don't have that much slop in anything, so they're pretty accurate. For those of you guys who are complaining about gear slop or whatever, this odom is super accurate. Yeah, and then we just managed to tuck in all of our pneumatics here, so there's none of this white stuff getting in the way of the looks of our robot. So it's all black up top. We're running a 4-wheel on each side. This is 450 RPM, 6-motor drive. Let's see. Drive motors are here. Yeah. So this allows our bot to have really nice acceleration and nice drifting as well with all of the omnis. Alright, and then really quickly, I'll go through the expansion of this system. So we're using we're using 6 shooters, so 1, and then the second one is on the other side. This cylinder is just hanging out here is we took off the actual cylinder used for it. So then, and then we have 4 more up top. The way it's loaded is it basically has like a rubber band from here to the standoff, and then the cylinder goes up and pushes it like this. Then the cylinders down here are connected to the system up top. So when we press the 1 button, then everything fires at once. We're not using these ones for matches because they're super painful to load up and they take too much time. We also don't want to get DQ'd. Even though they're running at a lower height, we just don't want to risk anything. So we run the 4 up top for our matches. And I can show really quickly how we load it and then how it fires. This is basically how it works. We have a band here, nylocks here, zip ties on the vertical standoff post, and then when these expand, then it fires. I'll just fire it real quick. Oops, wrong button. There you go. So it goes like that. Our bands are a little old and everything's pretty much like not really working anymore because it's super old. We haven't fixed it up yet. So that's the expansion. Imagine we have all 4 of them running at the same time. And then for the little ones back here, we use like 1 cylinder per launcher. It basically has this system that that the cylinder is wanting to retract, and then this resists the band power, so the band is stretched similarly to here, where it wants to release like that, but the cylinder's not letting it, I guess. And then when the system releases air, the band basically pulls it passively down like that and releases. I'll show it again. Alright, so as you can see, expansion's here, or the latch, I guess, is here. Then the band is here. It's pretty interesting how we use like a bent standoff to form this latch system. It's super cool. It's a banana. Drilled holes in the standoff, bent it, drilled another hole here, screwed it to the shaft collar. Then when I release it, it goes like, wait 1 sec actually. Alright, so when I release it, it goes like this, boom. That's not the right launcher for the job, and this chain is loose, so it hit that on the way out, but it's whatever. This bot is not working anymore. It's just to show. If you want to see our expansion, you can see the skills video that we posted on our channel. Let's see what else. I guess like one of the challenges of this bot was making sure that everything was had a good center of gravity. So with a lot of the high strength shafts in the front, we wanted to make sure that everything was super heavy on the back, so then it balanced out the weight. So we put the air reservoir, brain, battery, and the drive motors actually further towards the back compared to the front. So that let us have a good balance of the center of mass. And then we also have like a lot of custom Delrin pieces. These brackets are 37 degrees. We have this limit switch here. It basically, when the catapult retracts, then it stops once it hits the limit switch. Yeah, so that's how that works. Limit switch. Let's see what else. Cover the odon pods. Yeah, inertial sensor right here. We had problems with the shot of the catapult messing up the inertial, so we moved it down here, and it seems to have worked better. We tried rubber links, and it was pretty interesting, I guess, but this is we found this to be a good spot as well. Then we have auton selectors here, just some broken limit switches from our catapults here. Let's see, so we use the limit switch auton selectors so we don't have to use this brain. We don't want to like take it off and put it back on for the brain cover. And yeah, that's pretty much it. Thanks for watching. Good luck in Good luck.